In this podcast, we're going to talk about the Kelvin scale of temperature. Temperature is a measure of the average kinetic energy of the molecules, and it's a consequence of the motion of the molecules. So basically, we're talking about the average motion, excuse me, the average motion of all of the molecules in the sample. The Kelvin scale is very important because it is a true measure of the kinetic energy of the gas particles, much more so than, say, the Celsius scale. Here we see a graph, and I want you guys to graph this on your own paper. So here are 4 different gas samples at 4 different temperatures and pressures. And then I want you to graph them on this graph down here. All right. The way I scaled mine was I used 0.05 increments along this axis. So 0.05, 0.1, 0.15, 0.2, 0.25, so on and so forth, and that's pressure in atmospheres. And then along this axis we have temperature in degrees Celsius. So make sure you get that graph completed. And we see when we extended the graph all the way back by connecting all of our points, we see that it extrapolates back that when we reach 0 atmospheres, hold on if I can get this stupid computer to cooperate. All right, when we get to 0 atmospheres, that corresponds to negative 273 degrees Celsius. That's an important number. That's the correlation between Kelvin and Celsius. So to get from Kelvin to Celsius or Celsius to Kelvin, we use the equation K equals C plus 273. K being your temperature in Kelvin, C being your temperature in Celsius. So if you're looking for one, you just plug in the value of the one you have and then manipulate your equation to find the one you don't have. The significance of this negative 273 is that it tells us that 0 Kelvin is equal to 0 atmospheres. So that's why Kelvin is so important. It's a true measure of the motion. So if the molecules aren't moving like they aren't at 0 Kelvin, no kinetic energy, then we would expect no pressure, because pressure is the force or the collisions between molecules. Well, if molecules aren't moving, there should be no collision associated. This is one more thing that I wanted to show you in this podcast. This is the idea of STP, standard temperature and pressure. We just saw that 273 or negative 273 Celsius is equal to 0 Kelvin. So 0 degrees Celsius is equal to 273 Kelvin. When we're talking about standard temperature, we're usually talking about 273 K, because most of the time we're working in kelvins. It's also 0 degrees Celsius, but very rarely do we use degrees Celsius in our equations. Any one of these pressure values down here corresponds to standard pressure, but the one you're going to use the most often is going to be 1 atmosphere. So when I say STP or you see STP in a problem, you should assume 1 atmosphere is the pressure and 273 Kelvin as the temperature. Those are standard temperature and pressure.